Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another algorithm, that is BFS on graph, breadth first search on graph. So before starting this algorithm, let's see how we can represent a graph using adjacency list. So what is adjacency list? Adjacency list is a array of list. So we can write it down like this: linked list array. So this is adjacency list is a array of linked list. So if we represent this adjacency list like this, where on the left side we have source and on the right side we call it a destinations or neighbors or childs, whatever term we can use, it means the same. Now how uh, to create this adjacency list is, first we have to check either we will be given in the input a 2D array, right, from which we will get the source and destination. So either generally in the questions we are given with adjacency list already, but if not, we will be given some 2D array where there will be information of source, of edges between source and destinations. Either there will be information and we have to populate the adjacency list out of that. So suppose uh, in this information source and destination, uh, like we have in this graph, that if suppose for 0 it's connected with 1 and 2. So for from source 0, for source 0 we will be having destination as 1 2. So the source will go as a uh, index 0 of the array of the linked list, and the linked list will contain the destinations connecting 0 and all the destinations, that is 1 and 2. So this represents that there is a edge between 0 and 1 and there is a edge between 0 and 2. So 0 and 1 and 0 and 2 is represented by this. So first is the source and second is the linked list. So this is the linked list. So at this is an array of linked list. This is all array with the index 0 1 2 3 4, and this is all linked lists. So like 0 and this all will be linked list, something like this: 1 2 and 3. From 0, that will be our source. So for simplicity, in generally in the questions, for the simplicity, the value of the node is equal to, the value of node is generally equal to the index of vertex or node, same meaning. Whenever I say node or vertex, it means the same. So node or vertex, I can write for more clarity, the value of the vertex will be equal to the index of vertex, for the simplicity of the question, now how we will write, how we will create the adjacency list is, first we will check the 0th element or the 0th vertex. We'll see that it's connected to 1 and 2. We'll add in the linked list 1 and 2, that we will call the destinations or the neighbors. Now we will go for 1. We'll check that it is connected to 0, it is connected to 2, it is connected to 3. So we'll write in the adjacency list 0 2 and 3. Now for corresponding to 1, for 2 it's connected to 0 1 and 4, so we'll write 0 1 and 4. For 3 it's connected to 1 and 4, so for 3 we'll write 1 comma 4. For 4 it's connected to 2 and 3, so we'll write for 4 2 and 3. So this is a complete array of list. At the 0th index we have 1 comma 2, first index we have 0 comma 2 comma 3, 2 a list of size 3, at index 3 list of size 2, at index 4 list of size 2. So right part is the linked list and the first part is the source, is the index. Now let's see a Java snippet where we are creating the adjacency list. So here we see we have initialized our array of linked list with size v. Because we know in the beforehand the number of vertex, we know beforehand the number of vertex, so we should initialize, or we should take as an array of list, not as a list of list, so it will be faster. Now for the for loop we have so here we have only initialized this array, but we have not initialized the individual linked list. So for this we have to, for each vertex, for each index of the array, we have to initialize the linked list as well. And in each linked list we will add, for the corresponding source, we'll add the destinations. For the corresponding source we'll add the destinations. So there is one point. Now if you see, this is a undirected graph. So usually for undirected graph we add adjacency destination dot add source. So what I have written here? I have written here that if 0, if we have added 1 in 0 corresponding to 0, if we have added 1 corresponding to 0, we should add 0 corresponding to 1 as well, because this is a undirected graph. It's important whenever it's undirected graph, usually we, in the same for loop, we add the destination for the source and the same source as a destination for the destination as above. So they will act like, vice versa. This source will go here and destination will go here. Okay, now we have our adjacency list ready. Now we can iterate over the BFS algorithm. So for BFS algorithm we use queue, and we have created our visited boolean array. Now we have also initialized the queue. Now for every vertex, why for every vertex? Because it can be disconnected graph as well. Okay, so suppose the graph is connected and we start from the 0, from the 0th index. We check whether it's visited or not. No, visited at the 0th index is not 1, so we'll mark it as 1 and we'll add in the queue. Now we have added in the queue. Now this is statement, while queue dot size not equal to 0, queue is not empty, we'll extract 0, that is queue dot poll. Now we'll check for s, means we'll check for 0, the adjacent in the adjacency list. Check for 0 in whatever in the destinations or whatever in the linked list. Iterate through the linked list, all the elements. So we have 1 comma 2 and we will iterate as a for loop over them. So we'll first check for 1. 1 is not visited, we'll mark it as 1 and we'll add in the queue. We'll check for 2, right? It's not visited, we'll check. If not visited, we'll mark it as true, and we'll add in the queue. So both are done. We are done with this for loop. We'll go to the while loop. We again check the queue is not empty. We'll extract 1, the front element. Always remember the front element is removed. So this is removed. So we'll check for 1. What is the adjacency list? 0, 2 and 3. So we'll check 0, 2, 3. So we'll check 0. 0 is visited. If it's not is visited, will not do anything. 2 is visited, will not do anything. 3 is not visited, so we'll mark it as visited and we'll add in the queue, and it's done. We are done for the 1. Now we will again go to this while loop. We'll check queue is not empty, we'll extract 2. For 2 we'll check the adjacency list, that is 0, 1, 4. Now we'll check for 0, it's visited, we'll do nothing. For 1 it's visited, we'll do nothing. For 4 it's not visited, so we'll mark it as 1 and we'll add in the queue. For 1 we are over with this for loop. Now we'll go again the while. Q is not empty. Yes, Q is not empty. We'll extract 3. We'll check the neighbors. Neighbor is 1 comma 4. We'll check 1 is visited. We'll do nothing. 4 is visited. We'll do nothing. Now again we'll go in the queue. We'll check, okay, 4. We'll extract 4. We'll check 4. The neighbors are 2 comma 3, or the in the adjacency list we'll extract 2 comma 3. For 2 it's already visited, 3 is already visited. We'll do nothing. We'll out of this loop, for loop, and we are empty. The queue is empty. We are done with this while loop. Now we had started with I equal to 0. Now we'll increment to 1. Now we will check if it is not visited, we have to perform anything. So it's already visited, we do nothing. It's already visited, we will do nothing. It's already visited. So all the others are not visited or already visited, we'll do nothing. So we have successfully traversed using the BFS approach. Now why we generally need this for loop, as I said, when the graph is not connected. So usually what happens is when we start with 0, you usually traverse all the nodes, but when it is not connected, you have to iterate to the rest of the not connected nodes with this for loop. So let's see the time complexity. So for the time complexity, we are iterating over this v indexes. So we will it will be order of v. Now this while loop, so this while loop will be executed for every vertex. So for every vertex we are doing a constant amount of time, that is big O of 1, and this for loop will be executed like order of e. How order of e? So this while loop will be executed like c for this constant, and this for loop, as we have seen, this for loop for every vertex extracts the number of edges, so when we were at 0, we this for loop we did for 2 times, 1 and 1. This is equal to the number of edges whatever is in the adjacency list. So size is 2 here. So we this for loop for executed for vertex 0 2 times. For 1 it was executed 3 times, as mentioned, for 0, 2 and 3. For 2 it was executed 3 times. For 3 it was executed 2 times. So for every vertex it is executed n1 plus n1, c plus n2. C represents this constant when we poll, plus this for loop will be executed for each vertex. Some n1, for vertex 1 it will be executed n1, and n1 will be nothing the count of these edges in this first block. N2, n3, and so c plus nv, and this will amount to vc. This constant amounts adding up v times vc plus, and this summation n I over v will be this part will be order of e, all the edges in this adjacency list, 1 plus 2 3 4 5 6 12 for this case. So it will be order of v plus e, and o of v from above, so it will be order of v. So the total time complexity will be order of v plus e. Now let's talk about the space complexity. Let me erase this part. Now if I talk about space complexity, how much space complexity we have? So for creating the adjacency list, we require v plus e. So for at least we need for the vertex plus the edges, so it will be v plus e, plus we have created a boolean array, visited array, that will be order of v, of size v we have created, and order of q, that at most in the queue we can have v vertex for a worst case. So it will be order of v plus e, space complexity. Okay, yeah, yes. So just to clarify that for e, in case of undirected, sorry, for the time complexity, sorry, for the time complexity, E will be 2E, E will be 2E for undirected, but it will amount to V plus 2E, but it will amount to only V order of V plus E. Okay, hope you like this video, and after this watching this video, will hope I did my best to make you understand how BFS works on graphs. So please share and subscribe. It will give me motivation to bring more such videos in front of you. Uh, and don't forget to like and subscribe. Thank you guys. Bye.